Justin Patterson. I'm with QT Manufacturing. So what we're going to do is just show a quick little overview of the CIMCO Probing is an addition into Mastercam. The advantage of CIMCO is it can be ran on a variety of machines. There's not a lot of setup required. You know, we don't really have to look into doing much. Everything's built into the post. Also, it accepts more type of probes, not just Renishaws. So one I've actually been working on with a customer is a Maripos probe. That's the advantage of this. You get a lot more options. So the thing with the probing is you can do just about anything. You can align your workpiece to a G54. You can, clock C axis, B axis, A axis, whatever it might be. Along with do if-then statements to check holes. You know, we're going to go all over that, and then also do in-process inspection on the machine that'll actually print out to a variable of your choice. So what I have on my screen, hopefully everybody can see my screen. If not, let me know. It's just a simple part. It's actually out of our 2D training. I just figured this would be something good. I've thrown just a couple toolpaths on it just to kind of get us, to where we can work on the if-then statements. But the first thing we want to do is that this is running on, let's say, a Haas UMC 750. We want to make sure that the part is square to the world, meaning C-axis and B-axis in this case. So all the probing just runs through these two. I'm not going to be going over the surface probing. That will be a separate webinar. Along within the future, we're going to work on a webinar based on lathe. Probing on the lathe, but right now we're just focusing on just standard probing cycles for a mill. These can be added to whatever tool tab you want, so it's not required to be here in the mill. You can put it wherever you want. Inside of here, we have our 3 different categories. We have workpiece alignment, workpiece datum, and workpiece inspection. So for our alignment, this is where we're going to come in and let's say we want to clock C-axis. Make sure C-axis is clocked correctly. Okay, so I'm going to go into the angle, the workpiece angle, and it takes a second for it to load up. It is doing a C-hook in the background, but it will load. I've already created a probe. All they need on a probe is just for it to be a lollipop tool. That's it. I just made this a 6mm probe. And the other thing we want to make sure is that this is it's a static probe, meaning it will not turn the spindle on, okay? So from there, we go into our actual cycle. This is where we add our geometry. If I right-click in here, I can come in here and set points. For this, since I'm going to align C-axis, I just want to click 2 points on the front face. Either face will work. It doesn't matter, but I'm going to select points, and I'll come in here and select the corners of my stock, just here and here. And it automatically outputs like this. This actually flipped the wrong way, but it's simple. Come in here, the measure direction is set to negative and it needs to be positive. So where the hits are represented in the blue, this is everything can be changed. If you look through all of this process we're doing, you'll see all these variables can be changed. So the first point in X, do you want to move it? The first point in Y, do you want to move it? So if I simply just hover my mouse and click, I can wheel to change these values. So if I don't like where that X was hitting on the first hit and the second hit, I can simply wheel them in. Same thing with the measuring height, which how deep in the part we're measuring. It's the same thing. I can go there and just simply wheel that. And then you have the safety distance, which is what's represented by the blue. This is going to go throughout all the processes, so I don't have to re-explain all that. I can make my safety distance larger or smaller, whatever I feel. And then my clearance height, which is the actual overall height of this, how high do I want to go? So then I say, well, what offset am I going to update? Well, in this case, G54. In the axis I'm trying to update is the C-axis for the rotation. So I go ahead and hit that. It actually builds my probe routine right there. So when I come in here, I can replay this just like anything else. I come and take a hit. I come and take a hit. It'll actually do the work in the background and do the work offset for C to align this part. Same thing with a B. In this case, with a UMC, this is going to be a B. We're going to go to workpiece alignment, and I'm going to do it via X-axis. I always get these backwards. If one doesn't work, try another one. That's what I always say. So again, let it load up. I picked my probe. I go to my cycle, same thing. I'm going to select 2 points. I'm going to select the same 2 points I just used because I can move them. This, they're going to be in Z now because it's going to come and hit and make sure B is rotated correctly. So here I can simply, again, come in and move where I want Y to be. Do I want Y to be more in? Do I want my X point to be in? So on and so forth. If you don't want to do this, you can go in there and physically put points through Mastercam wireframe of where you want those hits to take place. But I found it so much easier just to come in and move this around. And the axis we are going to change is going to be axis B. Same thing. I can change the measuring height and all that stuff. Right green check. So the nice thing about this is I've now come in here and I've lined C axis. I've made sure B axis is correct. Now this is not always required. It's just I want you guys to know that this is something you can do. But now when it comes to actually aligning the part, I come in here and we're going to start working out of the workpiece datum section. Okay. So the first thing we need to do is establish Z axis. I have my axis for this part, the bottom center of the stock. I've created the stock boundary already with wireframe. And I go ahead and put wireframe on the part for when we get into the inspection side of things because it needs to read wireframe. But anyways, I'm going to go back to my workpiece datum and I'm going to go do a 0.1 axis. And what I like about this is it's giving me the macros on the machine that it's pulling this from. So 09811 is the one it's going to pull on the machine. This will list all those out based on what machine you're using. So if I go to the 1 point axis, I can, again, like I said, I can pick a point specifically. So what I'm meaning is I can come and do the old trick, right click and hold till I get green, hold till I get green. I get my red dot that's exactly in the center of this part. Or I can just click on a corner just like that and make this 0 and 0. You have options. The other thing you notice, you could be pre-active or post-active with this is what I call it. I could make these changes before because if you notice it's coming in X, I want it to come in Z. That's it. And then negative and positive obviously would just come from the opposite direction, okay? So again, this is where we're hitting. This is my safety distance and this is my clearance height. What offset am I updating? It's just that simple. That's all we need to do to update Z. And then as it comes to update X and Y, we have a couple ways we can do this. One of which is just simply doing a corner where I could go back and I could just check this corner, or we can do a full-blown rectangle. So if I come in here, I can actually say, I want to do an outside rectangle and it'll check all 4 sides. Or like I said, we could do a corner. We'll do 2 points on this corner, 2 points on this corner. 100 ways we can do this. So again, I can come in here. What's nice when I do a rectangle, it says, do you want me to go ahead and pull it from the stock, or I can pick lines, or I can select a chain. For this, I'm just going to have it pick the stock. Now, it didn't do a very good job at finding the depths, but it did find all the hits on the stock itself. So again, all I need to do is come in here and wheel this up to where I want, or I can hand key in a dimension, or your right click options that we're used to in Mastercam still are there. So you could do a distance between 2 point, a Z axis, whatever you want. Safety clearance, and then again, my clearance height. And here we're gonna say, what offset are we hitting? Well, we're hitting that offset. So we've done that so far. I mean, you can see how quick we've thrown all this together to simply align this part. So now everything's been aligned. We're rocking and rolling. We go in here and we face the part. We do some 2D high-speed stuff. We get to this helix bore right here. We bore this hole out, and I threw this tolerance on here just to throw it on there. Let's say it was 3/4 plus 3 minus 1. So with this, I want to go in there and I want to probe this hole to create an if-then statement to where I want, right after I get done boring this, go in there and probe this. Let's make sure this hole's falling within tolerance. So when we go into that, we're going to go now into a workpiece inspection. Anything that's not aligning the part is part of the workpiece inspection section of the probing. So I have 2 options. I can do an inside diameter 4-point or an inside diameter 3-point. It's just how many hits do you want to take. Notice they pull different macros to do that. I'm just going to grab the inside diameter 3-point here. And again, let it load. And there we go. My probe is there. And this is just a standard tool. I mean, if I might as well throw this in there. You go in there, it's in your tool library. You go, whatever you keep your tool in your magazine, just leave it in the tool library like that and pull it in every time. So inside of here, I only have one option. I have select an arc. So simply just select your arc, and it's pretty good at building this where we want to hit at. Again, I can change the X and Y, but now it's going to change from where I have selected, so I probably don't want to mess with that. I can also change the height that I'm hitting it at if I don't want to go that deep into the hole. And we also have first, second, and third point angles, which are these. There's first, second, and third. We'll utilize that when we check this radius here, how we can change that. But normally leaving it here for checking a hole is what we want. So we're going to go in here and we're going to create what's called an if-then condition. So right here, I'm going to check if-then condition. So there's three possible options this hole could be. This hole could be over the allowable tolerance. It can be below the allowable tolerance, need to be remachined into tolerance, or it can be within tolerance. So I'm just going to start at the bottom with within tolerance. If it's within tolerance, if it's within my 750 plus 3 minus 1, then I want you to go ahead and just continue on your merry way and go to the next toolpath, okay? But if it's coming, let's go to scrap real quick. Obviously, if it's over what I tell it, what do I want you to do? I want you to go and go to the end of the program because there's no need for you to run anything else. I don't need to waste any more machine time if this hole's blown out. So it's just as simple as saying that. So now let's look at the remachining side of things. The remachining thing, we're going to tell it that if it needs remachining, I want you to go to a certain operation. So I'm going to select this because what is the operation that did this hole? Pretty much what it's asking is it's going to check it, says it's undersized, and I'm going to get to how it defines undersized. It's undersized. It's going to go say, all right, well, it's undersized 3 thousandths, whatever. It's going to put 3 thousandths worth of comp into the tool I tell it to that drives this hole and go back to the operation I tell it to, which in this case would be operation 9. Okay, so operation 9, I want it to go back to operation 9 and rerun 9. So it adds the comp, runs the hole, bores the hole, and it's going to come right back and probe the hole again. And hopefully it should be within tolerance, so it goes out and continues on. So how does it know what's tolerance and what's not? Well, we have to do a little bit of math for this, be it on an instance like this, 750 plus 3 minus 1, we've got to find the true middle nominal. So in this case would be 751 plus or minus 2. So that's how they want to read that. They want to know what the tolerance is. And if you question this, the one we're working about is the dimensional tolerance value. If I enable this and hover my mouse over this, they're pretty good at giving this example. So for the dimension 1.968 plus 16 minus 0, the nominal tolerance is 1.976 with an H value of 8 thousandths. So that's saying that it's going to look at the hole should be 751 in our case, and the top of the tolerance would be 753, and the bottom of the tolerance would be 749. So anything over 753, considered scrap. Anything below 749 needs to be remachined, and they'll comp the value out to your nominal, which we're putting into our diameter right here. So it'd be 751. That's what it's striving to hit, is that exact nominal. So all I do is put in that nominal value that I had to figure from here, and then my dimensional tolerance, which in this case would be 2 thousandths. The only other thing we need to do with this is tell it what tool we want to update. So the tool offset number to be updated, in this case would be number 2, because that's what my my end mill is. That's literally all we do. So if it's scrap, go ahead and go to the end of the program. If it's within tolerance, continue. If it's not, add the appropriate amount of comp to the tool, rerun operation 9, and reprobe it, and we'll continue on from there. So green check. So it's built it into, and I will show you when we post the code how it does the return statements. It's kind of neat. They built that all in for you. So again, all this you can replay however you want, and you can edit these operations. So once we've done all this, we can go in here and we have the opportunity to where we can start inspecting parts after everything's done. So all our options again are in our workpiece inspection. So we can do an inside width, outside, so on and so forth. We can check holes. So let's go ahead and check this pocket here. So that's just going to be an inside rectangle. Okay. Again, pick your probe. And here I want to come in here and I can select lines. So I could select these 4 lines, or I could simply just select a chain. Just like typical Mastercam, come in and select your chain. There we go. So again, it does an okay job. It doesn't know that this is in the center here. It has no idea that that's there. So we need to simply come in here and give it a safety distance, because if we remove safety, it comes down here and hits, which is fine if these bosses did not reside in there, but they do. So I can come in here and I can make these a little bit less, a little bit more. I can change my clearance height. I can also change my measuring height, as we've already discussed. So for here, I want to go say, all right, well, I need you to show me the measurement results. So the measurement results that I can print out to the machine, this all prints out to a variable on the machine. So by here, I can do set point C, center X axis, so on and forth. You can see all these. The ones that I think are kind of nice is you get actual width, actual height, or you can have it tell you the deviation in the width and the deviation in the height, to where you know an actual value of how far the width is off of nominal. So let's say we, in this case, wanted to post out actual width and actual height. This tells us what variables they're going in. They automatically go in 1 increments. You can input your own variable. If you have a set number of variable that you want it to go in, let's say 10, 120, whatever you want, 10,020, you can change these to whatever variable you want. So green check that. So that's all. It's just going to come in here and it's going to inspect that center pocket, and it's going to output that to the variable you've defined on the machine. So it would be the same thing. If we went in and like the slot, we would just simply say an inside width. And for this case, we would just require 2 lines. And let it pull up, probe, select lines. I would simply just select this line and this line, and there you go. It takes my 2 hits. And again, I don't, make the movements to where you want. I can have it output my measurement, actual width, so on, out of tolerance flag, so on and so forth. So I would green check. There we go. So what I wanted to show you real quick is a couple more things, and then we'll open up for some questions. But let's say you wanted to check this radius here. Granted, if you measure this width, you got a pretty good idea what that radius is, but just for this, I'm going to go show you how to do this. Is we can go in here and we can say an inside diameter, let's say 3 points. You can get very creative on this. So if it ever loads up, there we go. Cycle, select my arcs. I'm going to select this arc right here. Now, if you look how it does its probe hits, remember it's this 0, 120, and a minus 120. Well, I can change those. So prime example is my first hit, I don't necessarily want it to be at 0. I want it to be maybe 20 degrees up. So again, you can wheel it, but as you can see, it's going in hundreds of thousands. So just type in 20. There's my first. Well, then my second would be this. Instead of 120, let's make it 90. And then my third angle, instead of a minus 120, let's make it minus 160. Right there. So we can define these angles that it comes in and hits these radiuses at. So it will, again, measure result. I can tell it, it's not, the only thing it will not output it as a radius, it will output it as a diameter. So remember that when you run to check this on the machine, it's going to be a diameter. But I can really define these probe hits really nice. One other thing I'd like to do, let's just say you need to know what the angle of this is. Well, this one you have to be a little proactive on. We need to draw a piece of geometry, a piece of wireframe on here. So I'm going to do a midway point, and I'm going to go to this top here because I can drive everything else Z depth a little bit easier. And I'm going to come and draw a line that's just that long. Let's make it 1.25. Let's see where that puts us, somewhere around in there, okay? That puts us at that 60-degree angle because I need 2 points to set this at. So inside my toolpath, I'm going to come to workpiece inspection, and I'm going to do an angle measurement in the XY plane. It's like how we located C-axis, how we clocked C-axis. It's the same thing, but we're using it now to check an angle. So coming in here, I'm simply just going to select 2 points, and I select this point and this point. And again, it's what side are we on, negative or positive? You just got to kind of pay attention. Now, it does not do a straight in move. It still looks at everything in an X and Y fashion. But I can come in here and say, move this, not that one, I'm sorry, this one here, my safety distance in. And it's not nearly as a problem. So I can come in here and say, give me the actual angle of this line. And now when that probe comes in here to hit, it'll come in, makes it hit, and will report that angle for that surface. So, I mean, that's kind of a quick little rundown. I mean, you can kind of use your imagination of the things you can actually do. One other thing you could do is, let's say you want to know where the Z depth is of this floor. It's just come in and do a 1 point, like how we set our Z axis. It's really your imagination's whatever you want this to be, okay?
Justin, what do you see as the primary uses for this?
Well, personally, I think the two primary uses that is the workpiece alignment and the in-process probing to make sure stuff is within tolerance. I think a lot of people are doing tighter tolerance features to where we can do the if-then statements. I think that's the most powerful, but mainly I do think the workpiece alignment is the best.
Can you also do something like if, let's say you're on a second op to make sure that the proper piece was loaded?
Yeah, correct. So that would be part of your if-then statement as well. You could go in there and take a hit of a feature and say that if it falls within this dimension of that feature, then go ahead and you're allowed to continue on. If it doesn't see that, then go ahead and you are scrap. And you could rather tell it to, you could put anything in there. You can tell it to go to an MO just to stop right there. That way the operator knows, anything like that. Yeah, you can use it for just that exact same thing. But to go back to this, just your simple Z depth is I can come in here and hit a point right here. And again, I just need to tell it that it's a Z move. And I can change the Y to come out here maybe a little bit more. And then again, what's nice is I can right click and I can do the Z coordinates of a point and I can pick a point there and it now changes that's my Z depth, pulling everything from Mastercam. So this would be the same thing. I would go in there and I could report the true position of this, the actual measured coordinates of that. So it will output an X and Y, but in this case, I just want it to be Z is what it'll output. So again, it's resetting the variables. So you kind of need to keep track of what variable number you're on. But I mean, we get paid a good salary to know these things. So we'll green check that. So I did want to show you real quick kind of how the post will look. Again, this drives everything through the post. Yeah, so this one in particular doesn't like to have the S0, which is, you're going to get this for each one of these. This, when you buy this and you have your post work done on this, we'll have that changed. We actually ran into that at a customer. I hit cancel on that one, but oh well. Let's pull this over here. So as you can see, the beginning cycles, it outputs all the probe routines throughout the process of the program. Instead of outputting everything as a sub-program at the beginning, it's in process. So as you can see, we go through here. Let me go through my tool changes. Let's look all the way down there at the bottom. Go up here to the top, click here, next tool, next tool. So you'll see when that probe comes in after this flat end mill, here it is. This is where we, let's see, tool 2. That's when we did the hole. Well, that's very end, isn't it? Yep, 6mm probe. Let me go back up here. Sorry, I got to find my helix bore. Tool 2. That's not a posted out. I just post out before this. That's how it always works. When you don't want something to work, it's not going to work. So I just want to show you these two here. Post these. Okay. Here we go. So there's your bore cycle. Okay. And then if you notice what it did is it inserts this probe label automatically, 199900. Okay. And then you can see the probe come up here and it gives you the if then statements. It's telling you right here that, see, here it is. So there's the diameter supposed to be 751 with our tolerance of 0.002. We're going to update tool 2. So if it's scrap, go to 1999, which is at the end of the program. If it's within tolerance, go ahead and continue on. And if it's remachine, go to 19990, which is what we witnessed up here. So it builds all that into the post for you. So it makes it really nice and pretty seamless. So I don't know if you guys have any more questions. Kind of, is there anything you need to ask? Nobody? Okay. Well, did you guys get hopefully all the information you need? kind of to show you how this would work. The implementation, I will say on this, we've been pretty successful on several different instances to where it's not a very complicated install. It's simply just getting the post logic added to your post, and then you buy the license. They do come with every install, comes with, let me pull this down here, maybe. Comes with documentation. So what's nice is they do have tutorials built in. So if I go to the Renishaw, they give you a getting started to where you can actually walk through this. It gives you, I don't know what that is. It'll actually show you kind of walks through these same kind of processes we did, along with a sample part and a sample post. We have this for the Haas, a Fanuc, a Heidenheim, and a Siemens. It's pretty simple to figure out. Like I said, I will get into a further webinar getting onto more surface probing. It'll actually come in and take several hits on a surface, but that'll kind of be a future webinar. But yeah, if anybody has any questions, if you think of something after this, don't be afraid to call your local salesperson or call into support, and you can ask for me, ask for Justin. I'd be glad to help you guys out however you need. And yeah, if you guys have any questions, definitely let me know.
Justin, can you hear me?
Yeah, I can.
Hey, I was curious if you could speak a little bit to the difference between this CIMCO probing and the probing that's on board within Mastercam.
Okay, yeah. So the probing inside of Mastercam is actually called Productivity Plus. So what Productivity Plus is actually is part of Renishaw. So those of you that run Haas's probably are familiar with Inspection Plus. That's the features that come on most Haas's with probes. All Productivity Plus is Inspection Plus that's driven inside of Mastercam. They're very similar. The one thing that Productivity Plus does over CIMCO probing is you can actually insert broken tool detection throughout the probing routines and tool setting. But to go with that, to combat that on the CIMCO side, that can all be built into your posts as well. The postability guys they write that into their post where you can get broken tool detection. So we can really combat that. What we've found as a company is we found that our implementations on CIMCO has been really smooth. The issues we run into with our Productivity Plus is they run what's called a RenMF file. That RenMF file has to match everything on your machine. You can preload the macro variables or the macros onto the machine, or you can have it posted out. We run into a little bit of issues with controllers and stuff like that. So that's your biggest difference. They all function the exact same. They all will do if-then statements. The advantage I will say on the CIMCO side of things is you don't have to build in the bookmarks for the if-then statements. It automatically does it, where in the Productivity Plus side of things, you have to go physically put in a probe statement in front of the Helix board, give it a target ID, say, hey, this is the target ID I'm going to go back to, and then I've got to create one after the probing to say, all right, well, if it's good, I need you to go ahead and go to this book. I call them bookmarks. I think they call them ID targets or something. I can't really remember what they call them. But yeah, so I just think personally with my experience, the CIMCO interface has been smooth and a little more better for the user.
Okay, thanks.
Hey, Justin, real quick, another thing that when you run the Productivity Plus, you can only run Renishaw probes.
Correct.
And you can only run Renishaw macros.
That is correct. Your
probing routines. Like, for instance, there's a lot of stuff that comes, probing that comes with an Akuma, various machine manufacturers, they have their own probing cycles, which with Productivity Plus, we can't call any of those. We can only do Renishaw designed and built into their system probing. And quite often, especially with turnkey applications that you may get from Makino or Mori or Akuma or Mazak, they'll probably write their own macro of probing, of which Productivity Plus won't be able to access or duplicate, which is why CIMCO has a little bit of advantage over that as well.
I think the other thing to add is in our experience is it appears in order for Renishaw Productivity Plus to function, you pretty much have to have a Renishaw tech on site to set everything up on the machine and the macros to get everything work. Because we've had places where they would put something on and then it's like the controller didn't match, then the Renishaw and RenMF file didn't match, and it's like with this we've had great luck because of just the way it handles the macros.
Correct. Yeah, anybody got any other questions?
Will this operate in the Mastercam for SolidWorks?
Will Mastercam for SolidWorks run C hooks?
That's a great question. I might need to look into that.
I don't believe that any kind of C hook development can also, because essentially Mastercam and Mastercam for SolidWorks is a C hook. So it'd be a C hook and a C hook. So I don't think it's possible to have a C hook into a C hook.
There you go.
Okay.
Yeah. Sorry about that.
Good question.
Yeah, and I'll pass that on to the CIMCO team. So what CIMCO, those of you that don't know, they're actually a Mastercam reseller. Where are they, Jeff, where are they out of? Are they
Denmark?
Denmark, I'm pretty sure. So, they're the same people that give you the editor that comes with Mastercam. So they are an actual Mastercam reseller. They make some really nice products. So that's the good thing is they got a pretty good support team that, I can ask Dennis that I've been dealing with there at CIMCO about that. See if that's something that could be looked at into the future about possibly getting that added to Mastercam for SolidWorks, just to bring it to his attention. But yeah, so again, yeah, if you guys have any questions, if there's anything you get off this and think of it, definitely don't be afraid to call in. If you want more information, like I said, contact your salespeople. They'll get you pricing information and all that stuff. But other than that, if no one has any more questions, I think we'll go ahead and call it a finish. And you guys have yourself a wonderful day.